So anyway, yeah, that means we're recording. So taking a look at example 1 here. It says BC is congruent to AD. So the first thing you always want to do is mark your givens on the picture if they're not already there. And a side note with this is later on down the page and on the back, not all the givens are listed, but they're marked on the picture. If the diagram provided has markings, those are counted as givens. So we know BC is going to be congruent to AD. So I can go right in on that, and that's a given. Remember, we're trying to show these triangles are congruent using one of these 5 shortcut theorems instead of using the definitions. Second given says that BC is parallel to AD. So I can write that down. Parallel to AD. Given. So what that does is it sets me up to say, all right, well, I've got something going on now. To show these 2 triangles are congruent, so I'm looking at this triangle and I'm looking at this triangle, I need to have 3 things. Either 2 pairs of angles and a pair of sides, 3 pairs of sides, be right triangles, have the hypotenuse and the leg match, something like that. I've got 1 pair of sides so far. When I see parallel lines, I want to start thinking about alternate interior angles is probably what I'm going to use. Because all those theorems from chapter 3 come into play. Alternate interior, alternate exterior, corresponding, same side interior. But I want congruent things, so that's only 3. One good strategy is to extend those sides and then look at that transversal. And that makes it look more like what we did in chapter 3 now. I can see my 2 parallel lines. I can see that transversal cutting across. Excuse me. I can see these angles that I've created. I'm going to ignore these segments over here and just focus on these 3 lines. So if I look, I've got an angle here. I've got an angle there. So that would be angle CBD congruent to angle ADB. And that would be by the alternate interior angles theorem. When you get stuck, you want to look for shared sides, because that's a reflexive property. You want to look for lines that intersect, because that'll create vertical angles. And you want to look for parallel lines, because for most of what we're going to do here, we want to be inside things. We want to be in the triangle. So we'll use alternate interior, or later on we'll do same side interior. We start looking more at like full polygons. But for triangles, we'll generally be that guy. So that's 2 facts now. Can I introduce a third one? Let's say I don't know anything about these segments over here. I've got a transversal here, but it's not going to match things up between my 2 shapes. BD is a shared side, though. Right? That BD gets used in both triangles. So that must be congruent to itself, yeah, by the reflexive property. And now I just have to figure out why I know the triangles are congruent. ADB congruent to triangle CBD. Now I just need to know what rule tells me that. Because I've got 3 things. I've got 1 pair of sides congruent, 1 pair of angles congruent, and another pair of sides. So I've got my 3 congruent statements. That's generally enough to say my triangles are congruent, just which rule tells me. And if you're not sure, you can always sketch one triangle all by itself. Take a look at what we know. We talked about that side. It matches that side. We talked about this angle. Matches that angle. This side matches that side. So I'm going to use side, angle, side. I've got 2 sides, and the angle sits between them. Just be careful you don't fall into the side-side angle. So be sure that you're in the right path before you do it. But yeah, if you have two sides in one angle, if it works out, it's going to have to be side angle side. That's the way it works. But you do want to watch, though, because, again, if this angle, for example, were one of these two, that's not enough to say they're congruent, because we don't have a side-side angle congruency. That just doesn't work. Right there for a sec.